everybody. I hope everybody's doing well. Last class we talked about slope, and today we're going to actually apply slope to where we can graph a line. So I want you to go ahead and highlight your title, okay? And I want you to read the first question on this paper, and let's see if you can figure out what it means. So the first question, it says, what does it mean to be a linear function? So in order for something to be a linear function, what does that mean? Okay. Well, that means it is a function that obviously graphs a line. So what does it mean to be a linear function? It is a function that graphs a line. I'm using this new program where my handwriting is absolutely atrocious, so I'm sorry about that, but I still think you can read it. So in order for something to be a linear function, it has to graph a line. Obviously, the word line is hiding in linear, okay? So then remember when we first started talking about linear functions, we then talked about what does the equation look like. So if I want to know what the equation looks like, will anybody remember what it has to look like? Well, it has to have, and it obviously has to be an equation with x and y in it, and in that equation there can't be any exponents. So what does the equation of a linear function look like? It has no exponents. Okay. So y equals 2x plus 7. That's an equation that does not have any exponents. If I had y squared equals x plus 2, obviously there's a squared, so that would not graph a line. Okay? So, graphing lines. We've already started talking about graphing lines, and I told you in the beginning that there are 3 different ways we can graph a line. The first way we can graph a line is by using a table. Well, we pick 5 values, we plug those values in for x, we find y, we then plot them on a coordinate plane and connect our dots. That's the most obnoxious way because it takes the most time. Then we talked about how we would find x and y intercepts to plot them on the x and y axis to then connect our dots and make a line. That's better than using a table, but it's still not great because we still have to solve 2 equations. So then there is this thing that's called slope-intercept form. I want you to give that a highlight. Slope-intercept form, it is the easiest way to graph a line. Okay. So this is the best way to graph a line. In order to graph a line in slope-intercept form, we need to know the slope and we need to know the y-intercept. So last class we talked about the word slope. Whenever you hear the word slope, 4 things should pop up in your head. The first thing that should pop up in your head is the steepness of a line. Okay, that's the first thing. Slope determines the slant and the direction of your line. That's the first thing you need to remember. Another really big thing you need to remember about slope is rise over run. That's huge. Rise over run. You rise and then you run. The third most important thing is the variable. What's the variable for slope? M. And the last thing that you have to remember is the formula, which is y1 minus y2 over x1 minus x2. Okay? Whenever you hear the word slope, these 4 things immediately have to pop up in your head. Slope means those 4 things. Okay? How about y-intercept? We talked about y-intercept, but it's been a little while. Does anybody remember what y-intercept means? Well, y-intercept is where the line crosses the y-axis. Okay, so when I am finding the y-intercept, it's where the line crosses the y-axis. And that's what you have to remember. So in order to graph a line, the only 2 pieces of information I need to know is I need to know the slope and I need to know the y-intercept, and I'm good to go. Okay? Alright, so let's go ahead and keep going. Notice you have the border, you have a box right here. I'm going to go ahead and highlight the border of this box. Oops, but let me not highlight it in black because that's very boring. Highlight, highlight, if I can highlight straight, it's the best we can do. All right. So there is a formal equation of a line. This equation is going to become very near and dear to your heart. Every time you hear the word equation of a line, you have to think about this equation, and it reads y equals mx plus b. Y equals mx plus b is the standard equation of a line. So whenever I ask you in class what's the equation of a line, you're going to tell me y equals mx plus b. Okay? So notice I have 4 letters. I have y, I have m, I have x, and I have b. Out of these 4 variables, which one have I just recently seen? Well, I've seen m. What does m stand for? M stands for slope. Notice m is always attached to x. That's huge. Always next to x. Okay? B is the new variable, and b is actually the y-intercept. Now, b is my y-intercept, and I can't use y for y-intercept because I already have a y here, and this y and this x, it's just kind of like doormen that allow you into a coordinate plane to graph a line. So y and x always stay variables, and m and b always turn to numbers. M is the slope, b is the y-intercept. Okay? If you take a look at this equation, actually, and before we take a look at this equation, notice b. Does b have anybody attached to it? No. B is always the constant. It's always the value that's by itself. It doesn't have a variable attached to it. Okay? And then, looking at this equation, which of these variables is 100% isolated? Well, that's y. Y is always alone. Y is always alone. That's huge. Okay? So just keep that in mind. Y is always alone, m is next to x, and my y-intercept, which is b, is my constant. Okay? So let's go ahead and look at some of these examples. It says, given the following equations, find the slope and the y-intercept of each equation. Sorry about that typo for in y-intercept. I'm going to highlight the word slope. What's the variable for slope? M. Put an M on it, top of it. Alright, and I want you to highlight y-intercept. What's the variable for y-intercept? B. So on these problems, I'm looking for M and I'm looking for B. Okay? So remember, if I come back and I look up at my equation up here, M is always next to X and B is always my constant. So if I go and I look at this equation, what variable or what number is next to X? 3. So that's M. So M equals 3. And it's always in good habits to always make sure M is a fraction. So how can I turn M into a fraction? I'm going to do 3 over 1. And why I'm keeping M a fraction is because of rise over run. Okay? So B is always my constant. It's always the value that doesn't have my variable. So what is B? -5. You with me? Let's jump over and look at number 4. I need to find M. I need to find B. So M is always next to X. What value is next to X? -1/3. B is always alone. B is always my constant. What value is my constant? -1. Look at 2. Same thing. M equals B equals. M is always next to X. M is -2. Always make it a fraction. -2 over 1. Why I'm keeping it a fraction? Because of rise over run. B is always my constant, so B equals 1. Okay? Let's try number 5. M equals B equals. M is always next to X. Now notice next to X there's no number in front of it. So what number is hiding there? A 1. So M is 1 over 5. B is -3. How do I know M is 1 over 5? Because it's next to X. How do I know B is -3? Because it's my constant. It's all alone. Okay? So I want you to go ahead and pause this video, and I want you to do number 3 and number 6 on your own, and then we will come back together and go over it. So if I look at number 3, m equals b equals, what does m equal? 1/2. How do I know? It's next to x. B equals 2. Y, it's my constant, it's all alone. Now look at number 6. What's m equal? Well, m equals 3/1 because it's next to x. But notice I don't have a b. So if I don't have a b, what does that mean b equals? 0. Okay? So hopefully this makes some sense to you. And let's keep going. Let's look at some of these challenge questions. Notice this equation right here. I cannot immediately assume m is 6 and b is -12. Do you know why? And the reason why is because look up at my notes. Y is always alone. Down here, is y alone? Nope. So, I got to get y by itself. So what am I going to do to get y by itself? I'm going to divide by 3. So remember when we started solving literal equations, we talked about splitting up our fractions. So y equals 6x over 3 minus 12/3. So now I can clean it up. 6x divided by 3 is 2x. 12 divided by 3 is 4. So m equals 2/1. B equals -4. And I'm done. If I come down and look at number 8, notice number 8, y is not alone. So I have to get y all by itself. So how am I going to get just y alone? I got to move 2x first. How do I move 2x to the other side? Well, I subtract it. So I have -3y equals -2x plus 6. Remember, the variables always come first. Also remember, I can't add 2x and 6 because 6 does not have a variable. Okay? Is y by itself? Nope. I now got to divide by -3. So y equals, that negative has to go on the top. So -2x minus 6, oh, oops, that's a positive 2x minus 6 equals over 3. So now I got to split up my fraction. Y equals 2x over 3 minus 6/3. So y equals, clean it up, 2x divided by 3, I can't. 6 divided by 3 is 2. Y is by itself, so now I can safely say m equals b equals. What does m equal? 2/3. How do I know? It's next to x. What's b? -2. How do I know? It's all alone. So I want you to go ahead and pause this video, and I want you to attempt to do 9 and 10 on your own, and then we'll go over it in class tomorrow. Once you finish 9 and 10, I want you to go ahead and flip your page. Alright, let's get to the fun part. So, how do I graph a line now that I know slope and y-intercept? I have steps to follow, so go ahead and highlight steps to follow. 1, 2, 3. Okay. Step 1. Let me not write in red. Oops, sorry guys. Step 1. Find slope and y-intercept. What's the variable for slope? M. What's the variable for y-intercept? B. So the first thing I want to do is just like what I did on the other page, and that's finding the slope and the y-intercept, M and B. Step 2, plot. That looks awful. Let me try again. Plot B on the y-axis. Why am I plotting B on the y-axis? Because it's the y-intercept. What does y-intercept mean? It's where my line crosses the y-axis. So I'm going to first plot B on the y-axis. Step 3, apply slope. When you hear slope, you should immediately think rise over run. Okay? So my fraction tells me how high I'm going to rise and how far I'm going to run. Okay? So a couple things you have to keep in mind. If m is a positive slope, you rise up. if m is a negative slope, you're going to rise down. You don't necessarily know what that means right now, and that's okay. I just want you to go ahead and write it. And then I want you to put a little cloud around it. Okay? So if m is positive, I'm going to rise up. If m is negative, I'm going to rise down. So go ahead and let's now take an example of practice. Look at example 1. So step 1, what's it say? Find slope and y-intercept. So I got to find m and I got to find b. What does m equal? 1/2. What does b equal? -1. Okay. So the first thing I'm going to do is, alright, so step 2. It says plot B on the y-axis. So because I'm using my iPad to record this video, everything might be a little off. So you just got to do the best that you can. So B is going to go on the y-axis. So I'm going to plot -1 on the y-axis, which is right there. Let's see if I can get that a little more exact. Nope, one more time. There we go. Plot B on the y-axis, which is -1. Okay, that's the first part. Second part, apply slope. Rise over run. So look at your slope. Notice my slope is 1/2. So the top is rise, the bottom is run. The top tells you how high you're rising, the bottom tells you how far you're running. So since the top is 1, I'm going to rise 1, and then I'm going to run 2. So I'm going to start at my original point, and I'm going to rise 1, and I'm going to then run 2, and I'm going to plot a point right there. Okay? I always run to the right. You never run wrong, you always run right. So you rise 1 because it's on the top, you run 2 because it's on the bottom, which is why you want m to be a fraction. So starting at your original point, you're going to rise 1, and then you're going to run 2, and you're going to plot a point right there. And now you're going to rise 1 from that point you just plotted. You're going to run 2, and you're going to plot another point. Keep going. Rise from that point. Rise 1, run 2, and now you're going to plot another point. And your points should be more exact, but because I'm doing this on an iPad, it's a little more hard. And then you're going to connect your dots the best that you can, and then you're going to draw arrows. You're going to make your line. Okay? So if I do this one more time to show you. So the first thing I did was I found my slope and my y-intercept, which was 1/2, and b was -1. I'm now going to plot b on the y-axis at -1. So b on the y-axis at -1. From this point, I'm going to apply my slope. The top of my fraction is 1, so I'm going to rise 1, and I'm going to run 2 to the right. I'm rising up because this is positive, and I always run to the right. So rise 1, run 2, plot a point. Rise 1, run 2, plot a point. And then you just keep going. Rise 1, run 2, plot a point. And then connect my dots the best that I can. Okay? So let's jump over and look at number 5. So step 1, find m and b. M equals, b equals. What's m equal? -2/5. B equals -3. I'm going to plot B first. B is always on the y-axis. 1, 2, 3. Oops. Let's try that again. Okay. Now notice the number on the top is 2, so I'm rising 2. The number on the bottom is 5, so I'm running 5. But notice the top is negative, so I'm not going to rise up. I'm going to rise down. So I'm going to rise down 2, and then I'm going to run to the right 5 and plot a point. Now notice if I tried to fall down 2 more and rise to the right 5 more, I'm going to go off my grid. Okay? You don't want to do that. So you don't have to plot a point if you go off your grid. You can, however, go in the reverse direction if you want. So if you wanted to go in the reverse direction, notice I went down and to the right. So I'm going to reverse both of those directions. So instead of going down 2, I'm going to go up 2. And instead of going to the right 5, I'm going to go to the left 5. So I would go up 2, and then I would go to the left 1, 2, 3, 4, 5, and I'd plot my point. Okay? So now I have a few more points on there, and now I can, with the best that I can, connect my dots. Okay? Let's keep going. Let's look at number 2. First thing I'm going to do, find what m equals, find what b equals. M equals 3 over 2, b equals 2. What do I plot first? B. B goes on the y-axis at 2. Now I apply slope. So looking at my fraction, how high am I going to rise? 3. How far am I going to run? 2. Am I rising up or down? I'm rising up because it's positive. So from that point, I'm going to rise 1, 2, 3, and I'm going to run to the right 1, 2, and I'm going to plot a point. If I can get it a little more exact. There we go. So notice now if I try to go up 3 more, I'm going to go off my grid. I don't want to go off my grid. So I go back to the original point, which is right here, and I'm going to go down 3. I'm going to go in the reverse direction. So instead of going up 3, I'm going to go down 1, 2, 3. And instead of going to the right 2, I'm going to go to the left 2, and I'm going to plot my point. And you can keep going. Down 1, 2, 3, left 1, 2, down 1, 2, 3, left 1, 2. And from there, connect your dots, which I did a terrible job. But if you have a ruler, life becomes a little bit easier. Okay? So go ahead and look at number 6. M equals B equals. What does M equal? Negative 2. So here's where you really want to make sure M is a fraction. Negative 2 over 1. And B equals 5. So I'm going to plot which one first? B. B goes on the y-axis. From here, look at your slope. Are you rising up or are you rising down? I'm going to rise down because it's negative, and I'm going to rise down 2, and I'm going to run 1. And you always run to the right. So from this point, I'm going to go down 2, and I'm going to go to the right 1. And I'm going to plot my point. And then I'm going to go from there down 2 more to the right 1. I'm going to plot another point. And then I'm going to go down 2 more to the right 1, plot a point, and keep going. Oops. And I'm going to connect my dots the best that I can. Usually you need at least 3 points. I always say it's pretty good to go through as many points as possible, just so you have them all on there. Okay. So the last problem I want to do with you is number 7. So let's look at number 7. So M equals B equals. What does M equal? Negative 2 over 1. How about B? There is no B, so B equals 0. So that means where am I going to plot 0? At the origin. Okay. From here, am I going up or down? I'm going to go down because this is negative. How far am I going to go down? I'm going to go far down 2, and then I'm going to go to the right 1, and I'm going to plot a point. I'm going to go down 2 more to the right 1, plot a point. Up 2. So now if I want to go in the reverse direction, let's talk about the reverse direction. So if I want to go up here, plot points up in this general area, instead of going down and to the right, I'm going to go up and to the left. So I'm going to go up 2 and to the left 1 and plot a point. Up 2 and to the left 1 and plot a point. Up 2 and to the left 1 and plot a point. And, oh my gosh, that looks terrible. And we're going to do the best that we can. So my expectation is that you've finished this worksheet. Any of the problems that I have not completed, you will complete on your own. Good luck, and I will see you soon.